Okay, so we've done the translations on this ball, but we haven't done any of the rotations yet. The rotations are quite easy, so here we go, we've got the ball sliding down, you've got a kind of bounce and a bit of a roll. One thing I should say that I forgot to is I did all that work and I forgot to save the scene file. So always remember to save your scene file, and more importantly, always version up. Always version up each time, because if you just keep on saving over the same file, what can happen is either the file gets corrupted and you've nothing to go back to, or perhaps you might animate in a certain direction and then realize that you kind of want to change things and you want to go back to an earlier version, but you might not have any. So always good to version up. Anyway, so here's our ball. Now, of course, I've taken a texture off, so it kind of looks a bit like it's rolling. It could be a ball bearing or plastic ball. And if we put the texture on by pressing 6, what happens is we can see that the ball isn't rolling at all, it's just sliding. So the next stage is to try and put some rotations on this ball. So I'm going to go to my layout again, and in this case I'm going to take off the motion trails. I don't need them. I'll take them off this as well, and I'm going to make sure I have my textures visible, and going to the top. Let's have a little look at this. So moving in, I'm making some assumptions here that you're familiar with these buttons here. These three anyway, but you may well not be. So just to kind of go over them, this is the move tool. So if I was to click on the ball, we can see here that here we have the ball. This is the y-axis, which is the one pointing upwards. Then you have the x, which is the one, depending on your orientation obviously, but normally it's the one coming out towards you, and the z, which is the blue arrow. If I click on this, is the one that our ball is moving forwards in. So those are the three axes, and those three axes exist also in the rotations, the x rotations, the forward roll, the z is the sideways roll, and the y is the side to side. You can see they're color coded. And then of course you have the same thing, but with this is the scale tool, making it larger or smaller. So if I was to pull out this, I'm not sure this ball can be scaled. The fact that they're grayed out means that you can't scale this, they've locked the rig. So anyway, those are the three. And just very quickly before we carry on, just one thing I touched upon earlier, and that is the difference between local and global scale. This is an example of a global translation. So this is the Y up. This is up on the scene. And if I double click on this, well, it says it's the object. Well, in this case, they happen to correspond. But if I was to rotate this ball slightly, if I just go like this, rotate it, and then press on this button, you can see that because this is local as opposed to global, what is showing me, it's showing me where the top of the ball is pointing, not where the top of the scene is pointing. If I go to the world, I can see that obviously doesn't change. So it's something to be mindful of, and you will, when you're animating, have to switch between the world and the object modes. Okay, I'm just going to get this back to where it was. And also, that also applies for the rotations. For example, if I rotate in the z-axis like this, these rotations are presently set to object. So you can see that the x rotation has changed as a result of the fact that I've rotated in the z. Now if I was to change this to world, nothing changes. So basically, in the case of world rotations, translations, they are always the same, but the object translations and rotations will change depending on how the object is situated. Okay, so that's an important thing to realize. Anyway, and in order to change them, you just double click on the icon and it should bring it up. Double click on the icon. I've got mine set to object. Okay, so going back to this screen, and we're going to do the rotations. The rotations are actually remarkably easy compared with some of the other bits and pieces. So for the rotations, what we're going to do is we're going to rotate around this axis here. So the rotations are in the red, which is the x-axis. So I'll go to the rotations, and I'm going to go down to the end of the ramp, which is approximately here, and I'm just going to rotate this round. And because we have, I'm going to get rid of this point here, because we have our, there we go, that's what it looks like in the graph editor. Now you see me kind of buzzing up and down like this and zooming this around. This is quite easy to do. If you put your finger, one finger on the Alt, the ALT key, I don't know what it is on a Mac, and one finger on the Shift key, and then if you right mouse click, you can kind of make this larger or smaller. And if you using the same Alt, Shift and right mouse click, if you pull in this direction, you can look at the key, scale it this way and that way, which can be useful. Yeah. So anyway, so we've got this. So let's have a look at this. Let's have a look. So this was just randomly done. So I've gone and made one point here at the beginning and one point here at the end for the rotations. And again, we've got the same thing happening, of course, that we have to be wary of. You can see that what's happening is the rotations are speeding up and then slowing down to a stop, because this is a flat tangent and this is a flat tangent. Now obviously what's going to happen is the rotations will increase as the speed of the ball increases. So I can't have a flat tangent here. We have to have one of these lines where, like we had in when we talked about translations in Z, remember the line increases upwards, the speed increases, and we need the same thing for our rotations. So anyway, let's have a look at this. I'm going to turn the mesh off. So we're just going to have a wee look at it and see if this looks like it's working. I can see that the ball's actually coming off the ground slightly there. I can fix that later. I'll do that later. At the end, I'm going to look at all these little details. Now the funny thing is, you can see that the human eye has enormous difficulties in picking up slipping and sliding in rotation, so you can get away with quite a lot. I mean, that to me looks like it's working. It doesn't really look like it's sliding. It's one of the advantages of doing this. So now again we have this problem. The ball goes down, it speeds up towards the end of the ramp, but then at the end of the ramp the straight line means effectively there is no more animation in terms of rotations. I'll just demonstrate what that looks like in the ball. You see it comes off, it stops rotating. Yeah. Now we want that ball to continue rotating, so we do what we did in the case of the Z axis. Remember, before we keyed it, the line was continuing up in this direction like this. So what we do is we go back to this and we say view, very important, infinity, make sure that's checked on, and then we're just going to go to the curves and post infinity, post as in after infinity. We're going to make sure that after this point it is continuing linearly upwards in this direction, and that will just continue these rotations. So when I go to this now and look at it, the rotations of the ball will continue. Yeah, it drops off. I'm going to get rid of these nerves curves so you can see this a bit better. So we've got this. Now of course we have this problem because the continued rotations of the ball we've got this just to continue, so the ball is rotating at the same speed where it leaves the ramp at the end of the ramp, and of course we don't want that. We want it to stop. So what we have to do then is, well, first of all we're going to find out where exactly does the ball stop. Well, we've got two curves here. We have the Y curve, and the ball stops bouncing at frame 48, but it continues to roll to frame 87. So therefore 87 is the last frame. Remember, 87 is the translations on the x-axis. This is the last frame. So when we come to our